All right, so if you're building anything with AI right now, I bet you're running into this huge unspoken problem. And here's the crazy part. Solving it has created one of the most important new jobs in the whole industry. So what is this role? Let's dive in and break it all down.
And really, it all comes down to this one simple but super powerful idea from Jeff Huber. The whole game isn't about how much information you can cram into an AI. It's about giving it the right information, exactly when it needs it.
Okay, so let's put a real definition on this thing. Context engineering. It's this brand new discipline, and it's all about carefully choosing what an LLM sees at the very moment it's supposed to think. What that means in practice is building systems that can find, sort, and combine the perfect little nuggets of information. And then, this is key, constantly making that whole process better and better over time.
But, why is this job suddenly so critical? Well, it's because of this really weird counterintuitive problem that pretty much every single developer runs into sooner or later. It's something called context rot.
Now, you'd think, logically, that giving a huge language model more information, that would just make it smarter, right? Seems obvious. But it turns out the opposite is often true. As you start stuffing more and more tokens into that context window, the model's performance can actually start to tank. It loses focus, and its ability to reason starts to fall apart.
And look, this isn't just some abstract idea. We've got the data to prove it. This chart here, it comes from research done by the team over at Chroma, and it lays it all out crystal clear. You can see exactly how different models handle longer and longer contexts. I mean, some manage to hold on, but others, they degrade, and fast. This is context rot, right here in action.
And this really gets to the core of the problem, right? The big disconnect. You've got the model providers marketing these gigantic million-token context windows. They show off these perfect needle in a haystack test scores, making it seem like you can just dump whatever you want in there and it'll work. But as Huber points out, when you get to real-world applications, that's just not the reality. Not today, anyway.
So it was this exact problem that got developers thinking, okay, there has to be a better way. And that search for a new approach, well, it led to companies like Chroma popping up. Their whole mission? To take the messy, unpredictable art of building AI ops and turn it into a real, repeatable science.
And this quote from Huber just nails the frustration that so many developers are feeling. I mean, getting a cool AI demo to work, that's one thing. But actually turning that demo into a solid, reliable system that you can put into production, yeah, that often feels a lot less like engineering and a lot more like, I don't know, alchemy? Just stirring a weird pot and hoping something good happens? And that right there is the whole point. The goal is to move away from that unpredictable, hope-it-works alchemy of demos and move toward a proper, systematic, engineering-driven approach that you can actually rely on. And that's the gap that this whole new field of context engineering is here to fill. And you know what? This engineering-first approach, it's clearly hitting a nerve with developers. Just look at the numbers. The open source engine from the Chroma team is now getting over 5 million downloads every single month. And check this out, it's got over 21,000 stars on GitHub. That's a massive signal from the community that, yeah, tools like this are a fundamental piece of the modern AI stack, no question. Okay, so how do we actually solve this thing systematically? It starts by completely rethinking what search even means when your user isn't a human, but an AI. And this table just lays out the difference perfectly. Think about it. With traditional search, your user is a person, right? They can maybe handle, 10 blue links on a page? But with modern search, your consumer is an LLM that can process so much more information. And that simple fact changes absolutely everything. The tools you need, the kind of workload you're planning for, the whole shebang. But here's the thing. Building the foundational tools for this brand new field, it's not just about cranking out code as fast as you can. It takes a much more thoughtful, deliberate, long-term way of looking at things. Let's take Chroma's philosophy as an example here. Instead of chasing every shiny new trend, they are maniacally focused on just one thing, retrieval, and doing it at a world-class level. And that means putting the developer experience first and foremost. It means patiently building the right thing, not just the fast thing, even if that takes a lot more time and effort. So where is all this actually going? What's the end game? Well, getting really good at retrieval today, that's just step one on the path to creating systems that are truly, truly intelligent. And what's cool is that Huber himself is the first to say, hey, as advanced as all this stuff feels right now, we are still in the super early days. The ways we get information into our models today, he says they're going to feel incredibly crude, almost like caveman tech in just 5 or 10 years.
So what does that future actually look like? Well, there are 3 huge shifts coming. First, systems are going to stay in what's called latent space. That's the AI's native mathematical world where it gets relationships, no more constantly translating back to human language. Second, retrieval won't be this one-and-done thing you do at the beginning. It'll be a continuous process, happening in real time as the model is generating its answer. And third, we're going to see much, much smarter ways of paging memory right on the GPU itself.
When you boil it all down, all of this incredibly technical work, it serves one simple, human-focused goal: giving AI a useful memory. And that's why context engineering is so important. It's not just some fuzzy, abstract idea. It's the practical, hands-on, roll-up-your-sleeves job that makes that memory a reality. It's the tool that gets us there. And that leaves us with a really fascinating question to think about as we move on from these, well, caveman methods we're using today and into this new world of continual learning. You have to wonder, what does memory for an AI truly look like then? And maybe more importantly, what incredible things will that allow us to build?